Switch off your cell phones or put them on silent mode. This is the post-lunch session. This is a panel discussion entitled Managing Space Control, Information and Mosaic C2 Enabled by Effective Ground Infrastructure. As you can see, our esteemed chair and esteemed panelists have already taken their seats on the dais. So we extend a very warm welcome to you all. We warmly welcome the esteemed chair and moderator, Lieutenant General PGS Pannu, PVSM, AVSM, VSM, retired, Chairman Space Committee on Defence SIA-India. We warmly welcome our esteemed panelists, starting with Lieutenant General Karanbir Brar, General Officer Commanding Dakshin Bharat area. We warmly welcome Mr. Pawan Kalra, General Manager, Business Development, Viking Optimum Solutions. Mr. Subhajit Chakraborty, Head of Business Development, Astrogate Labs. Mr. Christopher McIntosh, CEO, Methers Global, he will be joining us virtually. And Mr. Akshay Singh, MD, Avigway Technologies. So, once again, a very good afternoon and a very warm welcome. I hand it over to the esteemed chair. It's over to you, sir.
Good afternoon, ladies and gentlemen. I'm very glad that I have a limited audience. Actually, when we started talking about what we are going to discuss today, I had thought that I should only speak to a very, very limited audience because there are certain very close-chested secrets which I thought we were going to discuss. And I don't want this really information to be in the public domain. Now there are less number of people, maybe I can speak more. But the fact is that it is also important to put certain aspects in the public domain for the success of the concept that we are going to be talking about. Also, for the subject, we have actually chosen speakers with a lot of care. And therefore, before I get down to really opening out the discussion, I would want to go around the table and ask my panelists why are they here when we have to talk about something which is new, but also something that we have been talking about earlier, but we will talk about it in more practical terms as to how we can implement the space for ground use, how we can optimize space for ground use. After all, the users got to control the space. After all, the users have to make sure that that space that they created for themselves works for only them, but works optimally. What are the structures that we need to create either on the ground or in the space to have that space control and aggregation of knowledge and have the efficiency in the battlefield or operations as we talk about in real combat? So therefore, don't too much read into the heading of this discussion because it will unfold in front of you. So I would start from the left. Pawan, please tell them why are you here and what do you bring to the table today in this discussion?
Yeah, good afternoon, everybody. Myself, Pawan, from Optimum Viking Satcom. We basically provide the product and solutions on the Satcom, whether the station on the remotes. So we will go through those, what is required and why it is required. And then I'll put in one or two challenges also, which as an industry we are facing. So that will continue. Thank you.
General Brar is here because he's a practitioner. He's a warrior who's not only seen things happening at the apex level, but also on ground, mechanized warfare, armored warfare. He was head of the Armored Corps. With his experiences, how is the space that is going to help him as a warrior? General Brar, can you please talk about where do you come from as far as this aspect is concerned?
Okay. Thank you, sir. You see, I'll be talking about this mosaic warfare as a concept. Now, this concept is getting enabled because of AI and ML, and this is an improvement on the net-centric, which has not been wanting adequate because of the things which are happening, which I'll cover in my lecture. And of course, the background is, as sir said, since one has been driving all tech-related projects and one has operational experience all across, including abroad. And I took part in a SEO exercise in Russia also. So, one has seen a lot of things. So maybe in the time allotted, I'll be able to explain, because, whatever you are doing, it has to fit into the Mosaic web. And the war fighting concept has to be made clear. And then only the technology comes in where the various things fit in.
Thank you. Thank you, General Brar. Subhajit.
Good afternoon, everybody. I am Subhajit. I head business development for a company called Astrogate Labs. We are based out of Bangalore, and we concentrate on laser communication devices specifically for smaller satellites. This is the agenda with which we started almost 6 years back. When we say small satellites, our devices have form factors which are lesser than 1 mu, which means the terminals are round about 85 into 85 into 85 centimeters, which means we are uniquely positioned, and we are a full service sort of a provider. This is what I would love to talk more about, how scale brings more agility, scale and size brings more agility to the current discussion, and that's my take, what I bring to it.
Well, we're talking about space, then we have also behind me and far away, not far away because of the space that he's come inside the room, Christopher McIntosh, CEO, Moderator Global. He's on virtual. Chris, can you please tell us in first 30 seconds initial introduction, why are you in this room and what is that in this subject you're going to contribute? And then we will come back to our room physical presence, Akshay, after that. Okay, so Chris, what brings you to this room?
Volume.
Who's controlling the space? We can't hear you. We can't.
Okay, I'm not on mute. Can you hear me now?
Yes.
Okay, great. As an ex-British Army officer, I spent a career focused on enabling military armoured warfare remotely. And what I've seen is the situation change from sensors being just remote devices that collected information. I've seen them turn into not only information collectors, but decision makers and key support elements of network orientated attack and defense. And in order for us to be able to work remotely, we have to utilize the space connectivity that will allow us to be dynamic, flexible, and have the resilience to be able to operate when things start to go wrong. Therefore, I am extremely focused on how we can fully utilize the connectivity, the sensors, the weaponry that is being developed in the future. And that's what I see as being very much my part of this conference. And the only thing I would add to it is that cyber is an area that I've worked in for over 30 years, and I fully appreciate and understand the constraints and advantages of being able to control a secure connectivity. Thank you.
Thank you, Chris. You can keep listening to what your other panelists are saying. In between, I'll again come back to you for you to elaborate on what you have said and what role do you have in this entire creation of warfighting. Akshay, why are you here in this room?
Yeah, thank you, sir. Honored to be a part of this amazing gathering. I myself is coming from a research background, and so is my company Avigway Technologies, which is core focused since in last 3.5 years on the Mosaic warfare and certain military intelligence solutions and softwares, which till date I would say a lot of things were coming from outside. So we are developing these things here in-house, and working with the premier institutions of the country like ISRO, like DRDO, like the CSIR, and major laboratories, having the IITs onboarded with us. So that's where I am coming from. I'll be very happy to discuss more in detail on the modern warfare techniques and where we are standing right now. Thank you.
Thank you, Akshay. I think I can go there and speak for 5 minutes before I get the panelists to speak. Let me first take you to the battlefield. You have your own forces, you have your own support forces, and then you have adversaries eyeball to eyeball in contact with you, and you have the support forces of your adversary. There are certain contact battles happening right on the front line, from eyeball to eyeball. You're actually shooting straight into the bunkers or the soldiers on the other side. But also, how the warfare is unfolding with technology is that a large number of combat actions are going to be outsourced to machine and also would be supported by machine. And when I talk about machine, you can't have machines working on their own and going their own way. Machines got to be controlled. Machines got to be programmed. And if they have to be controlled and programmed, machines have to be designed accordingly. And these war-fighting machines, when are engaged in a kinetic battle, so they have to be designed specially for military purpose. But when they are not for contact or kinetic purposes, a large number of technology attributes can be dual use. Like, for example, networks, cyber security, hardening, terminals which receive the signals either in voice or data, satellites up in various orbits, doing various roles, but actually for the ground use where the war fighting is actually happening. So therefore, a country like of our size with thousands of kilometers of frontier, all may or may not be a combat zone. But for larger purposes, even if say 3,000 front of combat frontier can turn into combat. It is not will go into a combat, can turn into a combat. So largely the preparation has to go out at that scale. And where actually the war fighting happens is something where it is beyond you, but you have to be prepared on a broader front of 3,000 to 4,000 kilometers or whatever frontage a country has. How do you, in a networked environment, fight a battle of that scale and size? As far as depth is concerned, there is a tactical depth, there is an operational depth, and there is a strategic depth. And then there is a rear area, where all the support elements far beyond the battle zone are concerned can be located. But they are all part and parcel of the full nation going to war. Now that scale is a humongous scale. And when we talk about network centricity, and for a country like India, we have the border guarding forces who are under the MHA. Currently, the BSF and the ITBP and the Assam Rifles or the SSB are holding that same frontier on which this kind of a warfare can happen in the warning time, which may be available to you as we understand or may not be available to us. After all, Hamas attacked without warning. What happened in Ukraine? In Russia was there was some warning happening, but then, they said, no, these are false flag operations. Now, false flag operations can be taken into, buying time, but also orchestrating a surprise. But therefore, when you go into network centricity of that size and scale that I'm talking about, look at the number of elements which are going to be put on ground. And in my last report that we submitted, as far as the FICI is concerned, we said there will be 1 million sensors, combat sensors per square kilometers on ground. Look at the terabytes which will go into the terrestrial or the non-terrestrial plane. Look at the power that is going to come in. So therefore, in warfare, you say common operating picture. Common for who? Common for the nation? Common for the CDS? Common for the Army, Navy and the Air Chief? Common for a theatre? Or common for certain elements which are fighting more cohesively together in the combat zone? What is that? So therefore, no, network centricity can be seen as system of systems, because you cannot have the network centricity at that scale. So we will have certain systems of systems come together and we will have a common operating picture. Ultimately, what has now come down to is that you cannot have the plethora of 5G, 6G enabled data links, voice links secured to orchestrate that kind of a battle. But for India, it is possible to create a kill web, because the territories are fixed, the mountains and the valleys or the rivers or whatever you want to defend is understood. The commanders on ground have practiced it. The objectives are set, and they have exercised that at that level. At the tactical level, all the planning has been practiced. So therefore, what can happen is it is easy to create a small web. In that small web, a large amount of decision support system can be fed in. And that decision support system can be altered because it is click of a button. It is your own mosaic. You design the way you want it. You get up in the morning and design it. Tomorrow morning, change the design. Day after tomorrow morning, create something else. The whole thousands and thousands of kilometers will not get impacted, because it is that commander who's sitting in that limited area is creating the web on daily basis. Provided he has the reserves, he has the equipment allocated to him or in support of him, which can be allocated to him if required. So therefore, that kind of a switch is possible. So all that we are talking about today is that Internet of military things, which is a larger thing to happen, but Internet of battle things is something which can be actually activated by a mosaic, moving away from the network centricity, which will be understood differently. I'm not saying we will not be network centric, we will be. But to understand how the network centricity can be modified and created is what is important. So therefore, when we talk about space, launch on demand, we are also talking about the dressing up of shaping of the space for the battle. So you can shape the battle in a manner how you shape the space. And therefore you can have those kind of surges that we were talking about yesterday. Those can be thrown up rapidly at a time and place of choosing the type of satellites, smart satellites, or the configuration that you want can continue to happen on ground and they can be launched. But some can be aggregated, in which way I think Chris is going to talk about, that there can be a space control within space. There can be space aggregation by satellites in the space. There can be constellations which can actually shape the space for the battle on ground. So this is what we are going to talk about. So I will not take much time and straight away go down to our speakers. General Brar, please.
Jai Hind, Chair, the panelists, distinguished guests. So as I mentioned, I'll come straight to the topic of Mosaic. But before that, just a one-liner. The air power in around World War I or post that was just for observation. This is what space is some years back. So see how the air power has developed. So where the space can go, we have to have the right visualization. Okay, coming straight to the topic, Mosaic warfare. Now, Mosaic warfare is something which I'll try and explain. I really simplified the whole thing so that it is understandable, because if the industry understands, I think it will do a lot good to us, the concept which we are trying to propagate. Now, this is a very new thing. Now, Mosaic warfare is enabled because we have AI and ML, which I'll try and explain how and when. But let me, as I said, simplify. What is the basic warfighting concept? It is something called, which you would have heard, OODA loop: observe, orient, decide and act. So for a soldier, he observes with a weapon, even a rifle, he orients to the target, he decides to fire, he decides and then he fires. Now, this warfighting concept, when the armies grew, when the weapons grew, when the ranges grew, when the sensors grew, become larger and larger, and there was Air Force, Navy, Army. And of course, space also came in. So with such kind of a huge kind of a sensor and shooter, they had to be networked. Now, of course, the most best country which has networked everything is obviously the USA, and we talk of the 91 Gulf War where they networked. Now, this networking or network-centric warfare, as they say, what does it do? It collaborates all the sensors information into a fused picture of a common operational picture, gives it to the decision maker, and decision maker decides how to fight it. But this network-centric warfare is a kill chain. It is a chain. It is not a web. So, you know, it's a chain where you fuse all the sensors. The information is analyzed at their op centers. In fact, in US, you have various data centers right in center. The war may be in the Gulf. In the Gulf also, the thing was getting analyzed at US, and they had their communication and everything. But this chain can be disrupted. They had some recent war games because, you know, their main adversary, China, has studied their war fighting concept, and they have made sure, you know, the capabilities. They have studied the informationalized, and they come out with various other things. They have studied that you can break the chain. They have cyber attacks, so they will make it almost incapable. Now, as I said, I will use a crude example because फौज में लड़ाई करानी है तो सीधा order ही चलता है. So, crude example, let's say, what is Mosaic? So, you see, in a jungle there is a tiger, and there is a hunter with a .22. Tiger is, let's say, the main country, US or whatever, and the hunter was .22 China. Now, tiger is powerful. Obviously, it will attack and dominate. But what did the hunter do? He knew the tiger has these fixed paths. He dug pits. So when the tiger came, he fell in the pit. So all that power was nullified. So that is what, because, you know, they are net-centric. They are not fighting on the manual basis, and they are all over the. So if you nullify their chains, then, you know, a .22 can also kill the tiger. So, you know, this mosaic warfare actually is something to do that, of course, the tiger is required. So if they have a F-35, if the F-35 goes, it is a big platform which has all the wherewithal on one platform. So if you kill one F-35, I mean, it's easier to kill. But if you have swarms, you have UAVs, you have everything aggregated, then, you know, what do you kill and what you don't kill. So therefore, I know I had a small video. Is it playable?
If it gets played, is it playable? Is it connected?
No, I don't know. I had given it to them. You see this. You see, it's a swarm drone trial. So I just want to, because not that the audience doesn't understand, this was done because people are saying what is being done. In fact, Indian Army may be the first one which is inducted. Okay, these are drone zones, trials run in high altitude. So, you know, these are the drones which are linked together with artificial intelligence, and they are doing their various techniques of swarming, foraging, and you give an area for surveillance which is just marked on the map, and in that area, using artificial intelligence, they find out with the data library whether it's a tank or whatever. And after identification, obviously, if you want to have only surveillance or you want to target it, so you send your kamikaze drones there. Now it is self-healing network. You know, the drones are 50, 100. So even if you kill few, the task will be done. So imagine, I'm just giving an example just to explain. Now this whole thing is being operated from this tank which you see. And these are the kamikaze drone, and this is the actual one. So, you know, we just dropped something on the thing. So, you know, if you have a single drone which is coming, which you have seen in Ukraine war, okay, you can close it. Which you have seen in Ukraine. Now you have counter drone systems. But now if you have a swarm of drones, what do you do? So the mosaic warfare is basically, disaggregating, which General Pannu said, disaggregating, having contingencies, having multiple things, and so that, you're able to, what actually, again, not going into the politics of the whole thing, what Hamas did was, because they used all their means to disaggregate the technology. They used pipes. Iron Dome had a capacity. So the pipes, rockets had no intention of hitting anything, but they overwhelmed the system. So, this overwhelming, having contingencies, having this thing is what all is basically mosaic warfare. Now, where does the space come in? Now, there's something else which I want to clarify. Multi-domain operations. Now, multi-domain operations, unless people think it is operation in land, air, and space and all that, no. Actually, the definition is that the various domains collaborate and create effects as desired in other domains, and using dominance in one domain, blending capability, producing multiple dilemmas in a way which overwhelm them. So, actually domain warfare, we always had Army, Navy, Air Force, cyber came in and now space has come in. But unless all these 5 domains collaborate and creates an effect, so, mosaic and multi-domain are interrelated. So, quickly on to coming to the ground infrastructure, what the topic is about. Now, as far as satellites are concerned, everything has been talked about. I'll just give 1 or 2 points. As far as satellite is concerned, you can have software-defined satellites. You can have, which I mentioned yesterday, deploy on demand. There are companies, Dhruv Space I think is one, in which you can put satellite in space, having 3 satellites, and when you require, you see, for whether your SDA will identify, the adversary will identify this satellite, but then you deploy. Again, you are overwhelming the system. Then rockets 3D. I am from Chennai. I have seen the Agnikul system. It's a 3D rocket, launch on demand, very much possible. Now, satellites, we have been talking about ISR and communication. But in our area, since I was also, who took the first tank to lay in 1987, so I am aware of that area totally. Now, in that area, nothing else worked, which was highlighted in the previous session, unless you have SATCOM. So, localized SATCOM, neither whether it's a satellite based or whether it is based on drones. Now, coming to the linkages, as far as linkages are concerned, now linkages, like for example, I just showed you the drone, it can be via satellite also, and you can have a ground control. So, if the ground control gets interfered, you have a satellite system which is working. And ground infrastructure, the thing you have now is you have possibility of div headquarters also getting streamed onboard processing, and you can give a common operational picture right to the combat forces. And that again, the space will come in. And security, of course, lot has been talked about. I will only add one thing. The EMP hardening may be also provision. And, security should be by design, not as an afterthought. As far as NAVIC is concerned, it's been told. But there's something which, again, I was leading these projects of GPS and LNS. There's something called digital series maps. Everything which we make should be linked to our mapping system, which is DSM. Now, finally coming to all these, these are hardware. And I've explained the concept. The whole thing has to be linked through applications. So, finally, what is Mosaic? Mosaic is a concept and a software. So, here is where I think he'll come in, Akshay, where, the AI ML will decide where you overwhelm the sensor. You put in all the sensors into the web. You put in all the fighting systems into the web. And this web decides that which is the best sensor and which is the best system to fight. So, for this, you need AI ML, you need autonomous system, and you, of course, you need the decision control. There has to be a man in the loop. So, this is not a kill chain, this is a kill web. And it is also being called as the 5th generation warfare, or whatever because some countries are calling that. So, I will not take much more time. Just to end, you see, our visualization, as I said, you have an internet, there can be a space net also. So, if there are so many satellites which are linked through a regulatory mechanism, then definitely this thing of destroying a cyber net or internet, the question will go out of hand. So because, if there are 10 computers, yes, you can destroy on ground. But now we have an internet. So if you have a space net going with communications with this thing, and there are 3 things which are transported: communication, information, and third is energy. Now if you are able to transport energy through space, then things like HAPS or whatever else you want, it will be again a disruptive kind of a technology where your HAPS can remain as long as you want. You can maneuver your satellites. So energy transportation through space may be thought of. So I have finished. Of course, balance I'll take in questions. Thank you.
Thank you, General Brar. Pawan, we have a problem that in a tactical operation, the ground force commander who's fighting a tactical battle, smaller scale, as a kill web, wants to have his own satellite or web of his own satellite and wants to have their own control stations, own ground stations. How can you create a full infrastructure for a kill web where if everything else around you gets disrupted, it should not impact your war? Even if your neighbor or behind there is something happening, it should not disrupt your lines of communication, which General Brar was talking about, the kill chain. Because we are not dependent on that kill chain, we have to be self-dependent within the web. So can you throw some light on how the ground infrastructure and ownership of a smaller kill web can be empowered through technology?
Good afternoon, everybody. Hope you are able to survive after the lunch. Okay. Yeah, myself Pawan from Viking Satcom as a business development. Now, you know that what this the sir was indicating on the Satcom part or the Viasat. So, Optimum's Viking Satcom was incorporated in 2010 by Mr. V.C. Gaur, our director. So he's a 14-year-old now. So that, you know, that they find the gap, the things are missing. What were the missing? The quality, product and all those things. So that what Viking has developed, that we are the now trusted supplier, installer, service provider. So that what we are doing it now. And then we started like 14 years back. Now we have our own facility. Even managing everything. We do the spare management in our own facility. We have the test and repair center. Even now we have the manufacturing facility also. That I'll come on maybe snapshot on that what we are doing. Then we have more than 50 engineers giving the services all over India. And then, you know, like we were talking about Earth Station remote terminal. So when we think of Earth Station remote terminal, Earth Station means like 7.6 meter antenna, 8.1 meter, 9.3 meter, 11 meter, 13 meter, maybe more bigger. Then maybe on the feed on, then we talk about the LNA, receiving path, LNA, maybe SSPA, down converter, up converter, maybe waveguides, cable, connectors, modulator, demodulator. We talk about the Earth Station. Then maybe if waveguide, dehydrator, then you are reaching to the network side. And when we talk about the remote terminal, maybe we generally understand like 1 meter, 1.2 meter. Now in the aero side, we talk about 0.3, 0.6, 0.75, 1.2 meter. Maybe in the defense, we go up to 4.5 meter as a remote terminal. Then again, the same thing, LNB, mostly cases like LNB now. Then BUC, and then we talk about the modem, doing modulation, demodulation, and giving again to the network. So that your network, this end and this end, is connected through that way. So what, as a Optimum Viking Satcom we are doing, we are, what we talk about, except that network, we provide everything. You need antenna, you need cable, connector, modem, this side, and you know what, we were talking about reliable, seamless network. that cannot happen without reliable or that system without as a good product and good supports. So that's what we started. So we have a multiple products. We talk about like maybe Viking Satcom from the US. We have the product. We have the TerraSat. We give C band, KU band, K band, maybe going from maybe 4 watt to maybe 400, 600 watt. Even now, this Indian Air Force is using defense side. So many guys are using, private customers are using it. So what we try to do it here on the TerraSat, that it is we say as it's an intelligent BUC. Intelligent BUC means it has a multiple sensor. It senses based on it. It is a microprocessor. It control everything, and then you can monitor also, like NMS or maybe SNMP, something like that. Then we have a Teledyne Paradise, where it is that in defense side you require like SCPC links. It can work as a point to point, point to multi-point. You can have the mesh network. You can have maybe star type network. So that everything it can provide it. Then we have a multiple different way like AVL technology, Novella Satcom. We provide the BTR, down converter, ETI, dehydrator. Then Swedish microwave, Fluxy waveguide, Comscope, something like that. So we have all the flavor. Then what we try to do, that I was initiated the manufacturing facility. So we antenna control unit, antenna drive unit, we try to do some parts on that as Indianized local part, putting in that one. And we are in the process of making those items based on the defense requirement as a Make in India. And then we are working like we have design and develop 4.8 meter antenna KU band, and with the support of Bell, and we deliver to them. And maybe Bell comments are that it is performance is much better than what existingly they are using it. Then as a we are having some other project also. We are trying to do as a Make in India on the Satcom side. So maybe this platform I may not be disclosed now. Maybe next year we will be showcasing some Make in India product on that one. Then we are doing like we have done the one very big project of the FNET, where we refurbished existing network except the reflector, antenna control unit, antenna drive unit, and all the sensor and everything. We replace everything, and the installation and commissioning. So basically I was trying to say that we provide the product as a quality product and service, and so that we get the reference that we have not reached this place without giving the good service. Then I try to touch one more point, that we talk about the empty city. Maybe 50% of you must be knowing it, other may not be aware it. When we trying to say that now we have the in space, we want to have an open, global, and all those things, but still Satcom industry is struggling a lot because of lots of rules and regulation. One of them is right now indicated as an empty city. We call it as a mandatory testing and certification of telecommunication equipment. What happened in 2017, there was a regulation from the TEC side that all the telecom equipment has to be tested in India, get certified, and then those can be imported after that only. Now issue is that they talk about the telecom equipment and they put in the satellite on that one. Now what we are explaining to them, and even we explain to the InSpace, they are in agreement with that one. We discuss with the DOT also, and SIA is helping a lot on that one. What we are explaining that when we see the telecom, it's a thousand, maybe not a million, maybe thousand vendors, completely unregulated vendor, coming from a different country, maybe from China, this country, locally also. So there is no proper process of that one, from where those been tested, from where those in coming in. So the testing for those is right way. When we talk about the satellite, it is in worldwide, you see, very few OEMs are there, which is in the SATCOM industry or developing the SATCOM product. And those are also very few. And those are also supporting the very niche customers, like globally in the defense, globally very close customers. Everybody cannot buy it in the open market. So what, and then also see the numbers, and those equipment, it means when they are selling to all this, like in Indian defense also, we are selling it through BEL, ECIL, they have their own procedure of testing it to regulate it. So now what is happening, like, like one BUC, if like 400 watt BUC, maybe in a year, guy may be selling 1 or 2. So now what is the mandatory? You have to bring the unit in India, pay 10 lakh rupees and get it tested and get it done. So OEMs are struggling to get it done. Okay, so what we are requesting, like another point we were trying to explain to them, SATCOM is mostly, but in defense also, is a very close. It is not exposed to the telecom network. Even if in the private somewhere it is exposed, still telecom network has their own switches, router and controlling device on the data traffic. And in that sense, you can consider SATCOM as a only passive network.
Pawan,
passive
can we save some time for discussion?
Yeah, I'm just concluding it now. So what, and the number is also does not signifies that it has to be tested. Like if person is selling 1 or 2 modems in India, why they will go for a testing? So what, who will be suffering? OEMs little bit they will suffer. Okay, the guys working with the OEMs, they may lose the job. Okay, but parallelly what India will suffer if I have the option of buying 5 BUC different category, 5 different modem, different vendor, because if OEM is closing in India, that option will be very limited to us. So we will be very restricted. If tomorrow as an Indian Air Force, as an Army, I need 200 watt BUC, guy will say, I have only tested 400 watt, you need to buy this one. If guy need 600 watt, he will say, I have only 400 watt. Same thing on the modem, LNB, I'm talking about all this one. So what we are expecting that maybe from the defense, we should get the support. CIA is already helping. If we get some push and back from this one, maybe we can better explain to the DOT and the TC and we get the exemption of that one. We are requesting for exemption. Thank you very much.
Thank you, Pawan. As the web kill starts getting accepted, I think you have a good solution for that. I will go to our virtual speaker, Christopher, where we just spoke about the ground infrastructure. There is also a possibility to have space control from the space infrastructure. We can do information aggregation, we can build in redundancy, we can give options to switch from one mode to another. There are possibilities in ISR and different payloads that we have. We have options in communication. So Chris, can you please throw light on how can your company or your technology improve or contribute to space control from space and aggregation of all those possibilities to support Mosaic warfare?
Thank you. But firstly, and I would say most importantly, we are no longer in a situation where we have separate domains. And by that I'm saying that we talk about ground, the ground segment, we talk about the space segment, as if they are 2 completely different areas. What is actually happening now is they are merging and becoming one. And we are talking about connectivity. When we talk about Mosaic and we talk about different forms of sensors or different types of attack vehicles, such as UAVs, they need to be connected, they need communications. And those devices do not care whether that connectivity is being provided by space or it's being provided by terrestrial networks. Therefore, MEVERA is focused on pulling those 2 networks together to make them appear as one and make it seamless to the users. Now, the reason why that's really important is that if you go back approximately 10 to 12 years, you could have said that the military requirements were leading satellite technology development. But that's changed. That's changed to the extreme now, where commercial organisations are putting more finance into the development of commercial satellite systems than the defence ever will be able to. And that means that the defence and military have to look at what's happening in commercial space that's going to glue together the different networks so that they seem as one to the forces that are utilising them. Therefore, MEVRA is focused on resilience. Resilience being the key thing, because as operations and systems such as Mosaic are introduced, connectivity becomes king. Because without connectivity, you have nothing. And the Achilles heel of future fighting systems will be our ability to control them. Yes, we look towards AI, artificial intelligence, and we know that we can allow drones, unmanned tanks to operate for constrained and limited operations whilst they haven't got connectivity, but they will not be able to win a campaign without connectivity. Therefore, we are focused on knitting together and pulling together the different types of communications and connectivity that are required, whether they be ground or in space. So we are deploying a constellation initially of 12 satellites into MEO at 20,000 kilometers, sat between LEO and GEO. And that allows us to have a sensor network that can look into space to protect the space assets, to have a broadband provision which we can point and direct to any spot on the Earth practically real time, so providing broadband connectivity on demand where it's needed, when it's needed. But more importantly, as far as the resilience is concerned, it allows us to host payloads that will connect the GEO satellites and provide a relay when there are problems on Earth or at the GEOs themselves. So where you would normally have had interruptions in connectivity due to either a satellite being taken out of service or parts of it, or the ground network not being able to support it, we will provide numerous relays that allow those GEOs to actually earth and ground the information and the connectivity that they're actually providing. And when we look at the sensors that are provided at LEO, what MEVRA will be able to do is to provide a network that allows the information that they're collecting to be earthed via our satellites. So we are not reliant on independent, individual stovepipe connectivity for each sensor. And then we move on beyond the provision of connectivity, and what MEVRA is totally focused on is being able to provide in-space computation. Because right now, if you look at a LEO that's collecting, let's say, Earth observation information, it will discard and throw away over 90% of the information that it collects. It will not even be sent down to Earth. But what we all know is that there is information and intelligence that's being collected that is not ever being seen by human eyes. It's never actually reaching Earth. Therefore, by being able to provide in MEO the computational power to analyse what's being collected by the sensor networks that are at LEO or even on Earth, that allows us to enhance the information that is delivered to the warfighters. So the two main areas that we believe are key is the ability to provide resilient connectivity by having resilient communications and relays in MEO, and the ability to add computational power to the sensors that are in space that allow us to trigger other sensors and to maximize the effects of the data and information that's collected. And I finish by saying, without connectivity, sensors are useless. Thank you.
Thank you, Chris, for a very crisp description of your redundancies and offerings from the space to the ground. And I suppose it will be a very important alternative to the ground infrastructure, or it will strengthen the ground infrastructure. Moving away from the traditional space and ground infrastructure, Let's go on to little more deep technology on communication. So how can we establish optical links, or how can we use laser for communication? I hope it is secure, it is reliable, and will contribute to an uninterrupted web kill. Subhajit.
Good afternoon again. So it is the topic itself presented quite a few challenges for me, because I come from a typical business background, having handled business all my life. And incidentally, I replaced my CEO here in this conference. He is an aerospace engineer, I am not. But then it dawned that I can actually try and talk about technology in very non-technical terms. So when it always comes down to, first of all, I will take some references from my earlier speakers. So Colonel Brar made a reference to a swarm. Now, when you look back to the World War I and World War II days, the focus and intent of a country was to make bigger weapons. So the Tiger tanks, so the Panther tanks gave way to the Tiger tanks of the Nazi regime. They even built a cannon which could fire from Germany to the UK. So the focus was on size. But however, with time, especially when it came to military assets and space assets as they are, a country would rather choose to have $10 million satellites than have $100 million satellites, because that is what a swarm is. If you have a constellation, if you have a number of devices which work similarly out in there, and somehow one of them gets knocked off, you still have a possibility of regrouping and sending down, resuming the network and fighting. Now, when you started using mobile phones, I started using a phone like 12 years back, I think. I had a very strict father who didn't allow me to buy phones. You might remember that in those days, 10 years, 12 years ago, your phones had VGA cameras, or maybe a 1 megapixel camera. Any photograph that you took with that camera had a size of some 600, 700 KB. Now, each and every one of you have phones which has a 50 megapixel camera. The best photograph that you take with a phone like that is of a size of around 50 MB. What is the exponential rise in the size of each photograph? Your satellites were taking pictures from 1960s. Even Sputnik was taking pictures, and satellites are taking picture now also. But the quantum of data through pictures only, let us talk only about pictures, means that at 100 Mbps, that is what RF generally provides, you will not be able to download the payload of even a small sat on a daily basis. A small sat now generates more than 2 GB of data if it is doing regular Earth observation. So that data cannot come down through RF. That is where we sort of started thinking whether we can do laser for smaller satellites. Now, laser for satellites exists. It is there. The space agencies have satellites which use laser day in and day out. However, for a smaller form factor, like we went really into it, we thought about it, we worked. We also realized that there were very few players in the world who were doing it. So for smaller satellites, it became very evident that not only the terminals on the satellites, the ground station sizes were also going to get affected if we could pull that off. How? For the we were talking about bands, different type of bands yesterday. Satellites operating in some of the bigger bands require antennas which are just like Pawan said, like 9 meters, 12 meters, 30 meters is one of the sizes that are there. For the best, I would say, laser link that has been established by China actually, it is around 100 Gbps. Their optical ground station is not bigger than this room. So when you use optical, our ground station looks like I would say it is portable. It actually can fit on the backside of an army truck and can be, you can actually roam around with it. So you don't need those typical dome-type structures which you get reminded of when somebody says optical ground stations. So, yeah, that's it. And why is this important in a structure like this, when you have to have units which have to think fast? Information has to move within the mosaic very fast. That is where speed comes into a factor, and that is where I think laser plays a big role. I would be happy to take more questions and answer them. Thank you.
Thank you, Subhajit. Akshay, I would want you to please help us to make a kill web, because you come from the analytics and AI background for decision support systems. Is it possible for you to say whatever was said before you, how do you convert that into a tangible kill web? Can you explain that? Okay, please.
Thank you, sir. Thank you, esteemed panel and guests who have come here. So I will straight come to the topic and the question which sir asked, that how we can create a very efficient kill web. So definitely it involves a lot of network centric warfare which we are talking here about today, but at the same time not just only dependent on network also. So let's say let's take a scenario. So we are talking about a forward area, so where a lot of amenities are not there, and most of the decisions you have to make by yourself with the designated SOPs, which have been given and which are generally followed. At the same time, if there is anything which is of a high priority or high risk or high threat kind of a thing which has to be taken, this decision has to come from the command control center or a higher level of command control center. So for that, those permissions are to be taken. So we are talking here about that, why not giving the forward areas, why not giving the forward people little more power? So we talk about satellites are available everywhere. So the satellite communication, receiving the information from the satellite, receiving I would say the intelligence from the satellite, refining it, and then fusing it with the EOIR sensors, with the drones which you can fly there, with the information in real time from the drones which you can take and which you can even use for some kind of loitering missions as well. And let's take information from the LOROs, let's take information from the TTHIs, let's take information from the BFSRs, from other new radars, and why not combine it, why not make a mosaic of it, why not put it up on a map which you have made, which we call it Army map, Navy map, or Air Force map. So why not put it up on that, and you get the precise information, you get the precise decision where you can actually hit, and you are ready with the decision, I would say. So rather than having a lot of information coming from different areas, you can get a lot of information at your forward base, at your forward place, and then even then you can refine your SOPs. So let's say there is some designated SOPs that these alerts comes in from these 1, 2, 3, 4, 5 places, then you take the next decision. But I say that 4 places you get the integrated alert, and then you can take the decision in a faster way. You have the report ready, automatically generated from neural networks. We are talking about here AI, the real-time detections, real-time intelligence, the neural network making your report, the LNN model, the liquid neural network models, which are even making the decisions better with time. So it's not just having the decision today, what we are at what level we are getting a better decision. So we are working with places like ISRO for the LNN refinement and all those things. So so that's where things comes in, and the next step where it goes there. The next step goes towards the predictive intelligence, which General Brar sir said that where it will lead to. It will lead to such kind of decisions where you can think of that there can be this 10 new choke points can be there where the enemy might hit. So you can take the right decisions before time. And just to conclude, before I just submit to the panel, these are exactly the things what our company is doing. Avigway Technologies, a R&D backed organization working with, have the only core aim of doing military intelligence solutions for the country. Been 3.5 years and got success at various important places, and will be happy to connect post this session. Thank you.
Thank you, Akshay. The job of our syndicate was to actually work on a very complicated subject, but in a very simple manner. That is also a purpose of creating a kill web, to make sure that the commanders on ground are empowered with data, which is their data. They don't have to rely on data which is going to come from 1 million channels or thousands of kilometers. Their own data, downloaded by their own machines, for the usage by those machines. So therefore, you find that the empowerment is on having meaningful data, only that much which is required in that limited area. And ultimately, all these kill webs will connect with one another and make a larger mosaic. And that is how we will have network centricity come up. And the senior commander can pick and choose which mosaic to narrow on, or which, in case there's a disruption, to leave it to their own devices, because the SOPs, their understanding, the mission orientation, the objectives are very clear with the subordinate commanders. And they have to make sure that there are red lines, that you cannot do this, but you must achieve this in so much of time. This can be factored. And you will realize that the onus of taking decisions time and again in 24/7, highly staffed operations room sitting in Delhi or somewhere in national capitals will be avoided, because everything will come up processed. Every commander will be empowered. And I think that is where the technology and the power of AI and analytics and data will come in. Since we started 2 minutes late, can we have 2 minutes, 2 questions? And I think our esteemed panelists will be able to answer, I hope. Okay, so no questions? You want to say something?
So,
okay, 1, 2. Okay, 2 questions. You want to say something? Okay. You can answer.
Or sir, go ahead.
My compliments to the panel for bringing out a nice new concept. Right.
You can keep speaking. I think it'll save time.
So I just want a clarification from, especially from the technical side. What we are requesting and what we are envisaging is something like MANET, the mobile network.
No, sir, we are not much talking about.
Network, MANET as we call it, which is there in the formations in various levels. Is something similar? Which also connects the UAV, which also connects the satellite as per requirement, and dynamically it keeps changing. Dynamically, depending on the user requirement, it automatically configures the complete system in that manner.
I think in a way, yes. In a way, yes. But configuration here will be more specific. And it will be understood as you're configuring, and you will be able to get up in the morning and reconfigure.
So, just to amplify, sir, the mosaic warfare is by, firstly, equipment, or like swarm drones. Then is by communication systems, number of them, whether you have from space, whether you have direct. The third is from the thought. The fourth is how the AI ML will assist you. And then, of course, is the decision making, which may. So, mosaic is just not networked. It is networked in a number of contingencies, multiple contingencies. If one fails, the other is there. Then is the information also. The software itself should be multiple. You have a common operational picture coming. Now, a common operational picture of the maritime domain should be transferred to space and transferred everywhere. And I'll just make one point, sir. Though I have said it, and the panel may have also said it, and does come out in the media also with so much of this thing. These big platforms, whether they are aircraft carriers, fighter jets, tanks or something, they don't become irrelevant, because war is not won by drones. Ultimately, they are the ones on ground. Armored and infantry has to capture the land. It's only the way they have to be employed has changed. So somewhere it comes, Ukraine war, tanks or aircraft are not there. You know, the way they have to fight has to change, and this is what we are discussing.
General Pannu, you refer to the support forces being beyond the strategic, right? So does it include the logistics?
Absolutely. When you talk about the Internet of Battle things, Internet of Battle things are in the tactical battle area. But when you talk about the Internet of military things, they are anything that supports the tactical battle area. A war zone, a larger, rear area which is supporting logistics, everything put together, go into the realm of Internet of military things. So you can configure the way you want to configure. You want to configure the logistics only purely of ammunition. You want to do it only for casualty evacuation. You can build mosaics accordingly.
Yeah, but what is the sort of geographical spread of a tactical kill web?
As far as tactical battle area is concerned, it is largely between a brigade to a division. You can configure. And you can decide if the area where you expect a very intense operation to happen, you can have a smaller web. Where you think that the contact can happen, maybe probability is there, may happen, may not happen, you can have a larger web. But also, since you have, like, in a glass cockpit, you can move it around the way you want. So you can actually move it around the way you want. We can decide, okay, next week I'm going to have 3 mosaics out of this 1 mosaic. So it is possible, click of a button, you can even do that. You quickly generate a code, and that code becomes a web. So everything will react according to that code. If you're giving certain machines available on a QR code to that configuration, they'll all only respond to one. And you can always, as a higher commander, you can actually reduce these resources if you want to employ somewhere else, because you know where it is going to be employed. So on a given day, you know what is your orbat, you know what is your resources available, you know the task, you know what is to be achieved, and you are independent to quite an extent. So your own configuration, your own battles can be designed.
But that would mean that your logistics support will be in your immediate reach.
The forward echelons.
Yeah, so they don't go beyond the strategic area,
No, they will all, see, again, when I was explaining that to make a larger mosaic, you put all these kill webs together. So when you have a kill web, you can have a logistic web. You can have domain specialization in a web. So, somebody who's only dealing with casualty evacuation and who's dealing with the fighting strength, they will have a web of manpower. Like, what happens in NATO, you have a concept of J1, J2, J3, J4. J1 is personal, J2 is intelligence, J3 is operations, J5 is future planning, J4. So you can have those kind of configurations. So you build mosaics accordingly. So it means that there are no secrets which will go out, because within a limited area, you can configure every time that you want, but your mission is very clear in what you want to do. But you can use your resources the way you want to do it. Is that?
Yeah.
Yes, Pawan.
Yeah. Thanks. See, this I understand, this kill web and mosaic, but what are the machines which will be required there? What devices would be required over there? Is it a computer? Is it a mobile? What would be there, basically?
All of it, including sensors, mobiles,
sensors,
terminals, satellites, terrestrial,
so
non-terrestrial.
Would it be possible in the front areas to have all this equipment over there at one place?
Yes, I was talking about 1 million devices per square kilometer.
Is it currently happening?
Every machine will have a sensor, or every machine will have more than one sensor. So those sensors are doing different things. An artillery gun will have a couple of sensors working on one gun. So imagine the plethora of equipment, there are drones, there are missiles which are coming, there are aircraft which will get into your mosaic and get out of your mosaic. Till the time they are in your mosaic, they are in support of you. The moment you get out of your mosaic, they are in support of some other mosaic.
There's another project called man-unmanned teaming which has started. So, the manned is on the ground, the unmanned is in the air or somewhere, and he's giving you surveillance. The swarm drone is something like that. He's given you a surveillance of an area where he's destroyed everything and tanks are going like javelins were hitting in the Ukraine war, they would have cleared that. And that's why, this is a concept which will help. You don't need attack vectors, because attack vectors can't come in when there's war happening or there's firing happening. So you have, that's why I said, it's equipment, it is communication, it's everything. And you need to be connected, and 50 drones, a single person can't watch that and make a decision. The drones have to take a picture, fuse them, take out where the tank is and give that information. So this is where that AI ML come in.
Yeah, but AI ML also, something has to read that.
So that is happening. Like,
what would be reading that?
आपको एक physical example दिखाया सी ये तो it's happening, it's already happening. And I don't know, credit is not given. No country has inducted a swarm drone.
For that, there is one word: automation. That's about it.
So one question. So my question is to General Pannu sir. Sir, you pointed out this role of decision making done by AI and ML. I wanted to know how far is this going to impact the organizational command and control chain and civil-military relations per se, when it comes to giving a lot of autonomy to the operational commanders. Take decisions through AI and ML techniques. How is it going to impact the command and control chain?
I think never will any commander allow man out of the loop. The man will always be on top of it. So man in teaming, you can decide on the ratios of teaming. You can have one control 1 lakh, or you can have 5 people controlling 20. So as you have confidence on your autonomous systems, your teaming ratios will go in favor of autonomous systems. If you have lesser confidence on your autonomous systems, the teaming ratios will go in favor of manual control. So this is all configurable. Did it answer your question? Oh, you asked, right? Okay.
Resources would be available for those devices, and second thing is that for autonomous devices, since we are providing autonomy and edge processing kind of scenario we are envisaging here, so these AI algorithms can be deviated by the adversary also. So the security implication with the cyber thing is one thing, but AI/ML itself poses some security implication also. So how we are going to tackle that thing? That is the second question.
I think that's also a question to the designer, that how are you going to configure that? So I think this is a concern which is internationally, being accepted, that what are the laws, what are the responsibilities, responsible AI, all that is being spoken about. But the advantage here is that whatever is happening in the Mosaic warfare, you are actually restricting the place of employment. So it is not going to create one error will not go and have implications which are countrywide, because you are building small mosaics and you can localize it. That is the advantage.
The point which raises also here, which is edge-based AI ML processing, edge devices-based AI ML processing we are going to do then as server-based, and then the whole thing will go to the cloud kind of.
I suppose, Chris, can you listen and answer this?
Sorry, I could not hear clearly the question. Could you repeat, please?
Yeah, so question is, since sir was talking about Internet of Battlefield things, where we are going to have millions of devices in a very small geological area, and one thing is that how we are going to get the communication resources to these constrained devices. Second thing is that AI/ML based processing, if we are going to do on edge devices as well as the edge server and the cloud. So edge devices can be deviated by the adversary using the AML data, which data is being generated there. So how we are going to tackle these things?
Okay, I'll answer the first question. Regarding the requirement for lots of connectivity into a very small area, i.e. lots of sensors, lots of UAVs, etc., that are in a small geographical area, what we're seeing right now is that new systems such as the LEOs, i.e. your OneWeb, SpaceX, etc., They provide a very thin veneer of connectivity around the whole globe. So they are providing connectivity everywhere all the time. Now, what Mevera is focused on is that actually we don't need to be able to provide communications everywhere all the time. Instead, we need to be able to put lots of connectivity into a small area, a small zone, and move that zone as and when it's required. Therefore, my solution and what I believe is that the way we will connect these thousands and hundreds of thousands of sensors that are in a small location is by focusing our broadband into a small spot and moving those spots real time, as opposed to trying to spread all of our connectivity around the whole globe 24/7.
Thank you, Chris. I think we are going to carry our discussion for the tea networking time. General Brar, your last short comment before we wind up.
There were some questions on this thing, but another point which I want to highlight, the normal tendency, which in most armies is centralized control at the highest level, a lieutenant general or a major general, but Mosaic warfare wants decentralized control at the lower level. As General Pannu was saying, the webs, the decision has to be at the lower level. So therefore, everything of cloud computing doesn't go to some server. It is in that area. That guy takes that decision. So, this is an attitudinal change. And more than that, for all this to happen, we need highly professional guys who are both operational and technical. So that part of the training definitely is a, different gamut itself. Thank you.
I thank my panelists, and sorry for taking more time, but I think we started late. Thank you, Mandeep, for allowing us. Ladies and gentlemen, thank you.
Thank you, esteemed chair. Thank you, esteemed panelists. May I request you all to please join us for a photo op, all of you together. And ladies and gentlemen, we are still behind time, but we will have to curtail the tea break. Please try and come back by 3:45. It's a quick, short tea break, so please do join us back in time so that we can start the next session. At least try to start the next session by 3:45.